What's up, guys? Let's take a look at another CodeWars exercise. This one's called palindromic numbers. A palindrome is a word that's the same backwards, like Bob or race car, and you can imagine applying the same idea to some digits if they would be the same backwards. Now, there's a process for creating palindromic numbers. You take any couple digits, reverse them, add it onto itself. Take the result of that, reverse them, add it onto itself. And most numbers, after just a few steps of this, will give you a palindrome. Now, maybe there are some that don't. There's this idea of these Lycral numbers where you can put it through that process a million times, but hey, maybe the million and first would have done the trick. Luckily today, they're going to ask you about some that only take a few. They want to say, here's a number, how many times do you need to reverse it and add? And then what's the result when you do? So with 195, you'd take 591, add it on. Is that a palindrome? Not yet. So you reverse the result, add it on. Is that a palindrome? Not yet. Turns out that this one would take 4, and the final palindrome would be 9339. So we need to give it a string with both of those values. I like this problem because I can already think of a few different ways to do it, and they're all equally nice. So the classic procedural Python way is a while loop. If we're going to do something a bunch of times until we hit the yes, the win, then we'll do a while loop, and we say while it's not there yet, we keep going. So we could say while str number, because we're going to convert the digits and not just the quantity, while it's not the same as the reverse, then we do one step. We say number plus equals this guy. Actually, we need int again. Now I know that's ugly, but luckily that's it. Those are the only steps we need, other than just keeping a track of how many. So, again, the classic way to do this would be to have like a count, have an I, and initialize it at 0. And then when we're done, we return the count, and then a space, and then the number. And luckily, with F strings, I don't have to worry about types. Count is an integer, number is also an integer, even though we've stringified it a few times, and I don't have to convert it. That's already built in. So unless I messed up, I think that's going to work. Great, it works. But like I said, there's some other ways to do it, and I wanted to mention the functional approach, which is to say, hey, whenever we do something, change a little bit and then do it again, that's recursion. That's a function taking the result, putting it back through itself, inside of itself, and sometimes writing it that way is really nice and clear and kind of what we would say in English. So let's write this in a recursive way, even though it's pretty much doing the same thing. I'm going to say return this if it's good. So we copy and then we switch. Instead of going as long as it's bad, we return as soon as it's good. And then we can say else. Now I'm going to hit enter to have a new line because we're running out of space. Else we do this stuff, right? Now right here, we're going to, instead of plus equals, instead of like changing this current value, we're just going to send a new version back into the function. So we're going to say number plus this thing, get rid of all that because it's kind of in the way, and we're going to make count be a hidden parameter that we don't use the first time, but we do use subsequent times to say, hey, we're going to give you the 2 after the 1, or the 3 after the 2. So I'm going to go palindrome eyes of all that stuff, and we're going to use some parentheses to make it a little less ugly. Let's try that. Hey, that works just as well, because the while loop was saying, hey, as long as it's bad, do it again. This is saying, return it as soon as it's good, otherwise put it through the function again, which is kind of, in my opinion, less layers of stuff getting in the way, because running the function again is the same thing as running it a bunch inside of itself once, but it feels a little more honest. I don't know. It just depends on the problem and how you think about it. However, this is pretty ugly to look at, to see all this stuff going on, and really this is one expression that's covering multiple lines because it's so big. So another way you could approach it is to give each little step its own name. For example, testing the palindrome, that could be a function. It would make a lot of sense to say, hey, is this a palindrome? Yes or no. So I'm going to put that in its own little function, and I'm just going to call it pal to be nice and tiny. So we give it a num, and we're going to shrink the name a little bit. So let's say if pal number, and now that is outsourced to another little baby function. Hey, are you a palindrome? Yes or no. You don't have to tell me how you found it. I'm just going to give you the stuff. And then another little step would be this part where you're doing the reverse add stuff. We can put that in its own little step. Again, I'm going to shorten it to num. And then we just go rev add of, I'm going to shorten this to num too, why not? And while we're in this shortening idea, I'm going to change this. Normally if you're counting, you'd say in. In is a classic math way to count, but I don't want to have num and in right next to each other. That's too similar. So we'll go with I. Maybe I'm taking it too far in the shortening idea. But now you can see how this is really back to the kind of thing that would fit in a line. And since the other guys are lambdas, maybe this could be a lambda. Then we won't have to say return. No. And see, that works just as well. And we still have one line sticking out a bit, but not much, right? This is a very clear single expression. Return a string if it's a palindrome, else we put it back through the function. And I do kind of like this because you could imagine using those other steps individually. You could imagine testing whether something's a palindrome unrelated to this function, right? You could imagine this reverse add thing being used somewhere else as well. So they're named, even though the names are very short, they're still named. And in my opinion, reading this is kind of nice. I did all three of these recently, and they're all perfectly fine. They all work. Let's see what other people did in case there's a fourth idea. First one, while loop, great. I love it. Next one, recursive, great. I love it. And we'll see pretty much those again and again. If we scroll down, you'll see, hey, we got a while loop. They use while true instead of while a condition because, hey, we were going to return anyway, and return kicks us out, so that works. This one has basically the same idea. It's just a little more stretched out where each thing gets its own line, and makes sense to me. This one, I don't know. Something about the names doesn't make sense to me, but maybe my names don't make sense to this person, so it's all right. This one, love the names, love the idea of spreading it out, but this can be shortened. You can just use the str conversion on strings instead of doing it by yourself, checking how many tens and how many hundreds and so on. In fact, that is what it does. When you str an integer, it just takes the modulo for each power of 10. That's pretty much exactly the same as my first version, and it works just fine, right? That one's pretty cute with the join instead of the f string, but it's the same idea. And all around you'll see similar stuff. But I loved this one because the math process is kind of easy to describe. You say, hey, reverse it and add the numbers. Putting it into code really tells you how a person thinks. If they think in a loop, or if they think in recursion, if they think in giving things little names, or cramming it into one giant line, or separating out each function as a big old def with breathing room. They all work, but it's kind of nice to consider the pros and cons of each. At least I thought so.